Hello, bearded bee people. Welcome back to B&K Bees for the third part of our Beekeeping Crash Course. This is, in fact, the third part of the honeybee biology portion, and we're going to talk about the natural bee year. And what I mean by the natural bee year is what a honeybee colony wants to do, what a honeybee colony would do without human intervention, because I feel like it's a very important thing to understand. Because some of the stuff is kind of counterintuitive, and some of the stuff is just essential to us understanding so that we can work with the bees as opposed to against them or against their natural tendencies. So let's get into it, because there's a lot of information, as there is in every part of this crash course. So we're going to start in the spring, what we think of as the beginning of the bee year, and so we're going to start in March. Bees come out of their winter cluster as temperatures start to rise in March and April. They have already been rearing brood to some extent, but as temperatures increase, they will greatly increase the brood nest. Mite counts are normally low for healthy survivors at this time of year, although they can be very high in colonies that will soon see death. So there are a lot of late summer die-outs. Most of the cases for late winter die-outs. Most of the cases for late winter die-outs are starvation, food, because that's the time when the stores are getting lowest. But you will also see some that just couldn't make it in terms of the mite load. As the bees died, the mites found other bees to latch onto, and the mite-to-bee ratio went crazy high, and so they're on their last legs. But generally, in a healthy survivor, the mite counts are low. The first blooms happen here in mid-Michigan or West Michigan in early to mid-April, and those consist of maples and willows and skunk cabbage, and those are definitely important pollen-producing plants, but they don't give anything as far as nectar, so be aware of that. In late April and early May, then we're going to start seeing those little yellow dandelions all over the place, and that is normally our first influx of nectar. So once again, be very aware of the fact that just because you might see bees coming in with that yellow pollen in March and early April, that does not mean that they have any carbohydrates at all. And although protein is an essential thing for brood development, carbohydrates are essential for just about every other thing, for the energy produced by these bees, or the energy used by these bees. So the influx of nectar and abundance of pollen in early May bring an inflation of brood and bees to the overwintered hives. Hives can grow at alarming rates during this period of the year. Swarm preparations have begun at this point in most, if not all, sizable and healthy survivors. So right when the food is right in the spring, these bees are going to grow very, very, very quickly, and they can get ahead of you very quickly, very easily. With the inflation of the brood nest comes the ability for the honeybee's primary pest and primary foe, the varroa mite, to increase its numbers as well. Varroa mites produce more varroa mites in brood cells. So right before a brood cell is about to be capped, a mite will sneak in there and lay eggs while the bee is developing underneath the capping. And when the adult bee walks out, the mites will walk out with it. So when we greatly increase, or when our bees greatly increase the brood nest inside our hives, the ability for those mites to grow in numbers increases as well. So we have to be aware of that. All right, now we're on to May and June. The bees that are being reared now can make or break the year for each colony in terms of honey, at least here in Michigan, where we have a short window of honey production. An abundance of food and available space to lay eggs is absolutely necessary for each colony to build up enough workforce to be effective during the short nectar flow, and swarming problems can just absolutely destroy that at this time of year. At some point between the beginning of May and the end of June, most surviving colonies will swarm if we don't interject. These are reproductive swarms, and they are a sign of a successful year for those colony of bees. So if you're a new beekeeper and you have your first overwintered hives, and you walk out on a May 15th day, or maybe closer to Memorial Day, if you walk out there and you see just a massive swarm on a tree, obviously your first instinct would be alarm and oh no, I'm losing my bees. But the next instinct should be, wow, well, at least I know that those bees did everything the way that they should. They did everything the way that they wanted to. They did everything the way that they're geared toward. So, you know, a reproductive swarm, a massive reproductive swarm in May is a disappointing thing if you lose them, but it's also a sign that you did everything right up until that point, other than, you know, preparing for the swarm. So, these are reproductive swarms, and they are a sign of a truly successful year for the colony of bees. The parent colony, being left filled with brood, quickly recovers in population and reaches peak population for the year sometime around mid-July. Now, I say recovers quickly in population. That's usually because we'll get in there and pull all the rest of the cells and make sure that they're not going to continue to send out after swarms. But we'll leave all that stuff out and continue talking about the natural bee year. So they'll probably swarm at the beginning of spring and then try to make up those numbers and build themselves back up before winter. All right, now summer, July and August. At some point around mid-July, the brood nest starts to shrink as the bees begin their winter preparations. Nectar and honey will start to encroach more and more into the brood nest as late summer evolves. Now, this is another area where it's counterintuitive to our thinking. In our first few years as beekeepers, the idea of starting to think of winter in July is very alarming. I mean, it's counterintuitive as heck. But that is exactly what these bees are doing. So right at the beginning or right at the midpoint of summer, that brood nest will start to slowly shrink. And you're going to notice that the brood area on each frame shrinks and the honey band around the brood nest is going to grow. And that is a natural and normal course of things. So, due to a population phase shift as the honeybee numbers decline, the varroa mite numbers ascend, increasing the mite-to-bee ratio dramatically as the summer wanes. And so what I mean by a population phase shift, and I have a slide later that'll show it graphically on a graph, but what I mean by that is, as the bee numbers start to grow at the beginning of the year, it takes a little bit for those varroa mite numbers to grow as well, because we need more bees to create a larger brood nest, and then only when we have that larger brood nest can those varroa mites really start to grow themselves. So they're a step behind in the population growth, or maybe I should be doing it this way. So they're a step behind in the population growth, and they will hit their peak population at a different part of the year than the bees will, which causes a real problem for us in late summer. And once again, I'll have a slide that more clearly describes that here in a couple slides. So in August, as the summer nectar flow comes to an end and pollen becomes more scarce, which is that epigenetic influence to create winter bees, a new type of bee is created. Eggs that are laid from this point on develop into winter bees. These are, with the exception of the queen, the most important bees to a colony's survival, especially here in northern climates. These winter bees are different in the fact that they have enlarged fat bodies that can store nutrients for use during the winter. These bees can also live up to 6 months as opposed to summer bees living for around 6 weeks. So the health of these bees is so important, which is one of the main reasons why varroa mite management before late summer is just so crucially important to having your hive look healthy and be a survivor in spring. So the healthy development of these winter bees is truly essential. I need to just read this stuff and quit talking and then reading it over to double it up. So the healthy development of these winter bees is truly essential. If they are parasitized as larvae by varroa mites, the development, size, and function of these ever-important fat bodies are damaged, and colony survival is threatened. The removal of varroa mites after the larval development in most cases is a too little, too late scenario, which is why when people ask me what should I do about varroa mites in September, I always say, well, you originally should have asked me that question a couple months ago. Because although we are only starting to think of the end of summer at the end of summer, these important bees have been being created for 6 weeks or so, and they've been in a bad situation up until that point, and taking action in mid-September is a band-aid on a gangrenous wound. So yeah, definitely make sure that you're taking care of these varroa mites. Right at the midpoint of August is my go-to date. So now we're on to fall. In September starts the fall flow for us in Michigan, and it can last as long as a month. It consists mostly of goldenrod. It's an important bloom for us. Once again, in many cases, the fall flow is an important time for a honeybee colony, as the summer nectar influx might not have allowed enough weight to be gained. It can take up to 150 colonies of honey to get one colony through a long and arduous winter, and the goldenrod flow can allow a large colony to bulk up so much. I mean, you can really take off almost all of their honey at the end of summer and then let them get completely up to weight in goldenrod some years. Don't depend on that 100%. Be prepared to go buy some sugar, but the goldenrod flow can be a real savior for us here in the northern climates. So the brood nest continues to shrink as the fall season develops, and honey replaces the bees as they emerge from the brood nest. This will kind of cause a congested looking hive in September and October, but that is exactly what you want to see. What would definitely be a swarmy hive in May is a good looking hive going into winter in September and October. So don't be worried that there's honey everywhere. That is exactly how it should look at this time of year. So the mite to bee ratio sees its peak in mid to late fall. This can cause many colonies that looked healthy and vigorous in midsummer to collapse quickly from both direct parasitization effects and the diseases transmitted by the varroa mite. So what I mean by that is there are direct effects that happen when the varroa mite punctures the bee and starts to feed on the fat bodies and the hemolymph. Actually, I don't think it's hemolymph that we believe they're feeding on anymore. It's pretty much just the fat bodies. Either way, there's a direct effect, a direct weakening of the adult bee that happens while these varroa mites are doing that. But then there's also a secondary effect, because when these varroa mites are kind of piercing these bees' bodies, they are injecting diseases that they may have on them or that they may be carrying in them. So there's just so many problems that come with varroa mites, and so much upside to making sure that these varroa mite numbers are taken care of. Okay, so here is, and this is from scientificbeekeeping.com, which is the best website for bees and beekeeping that I can recommend to you. Randy Oliver has done so many studies on so many things that are so important to beekeeping that if you just are going to follow one website, scientificbeekeeping.com is the one that I recommend. So this is that phase shift that I was talking about before. You see that the bee numbers peak here in midsummer, and then they start to dwindle, and as they're dwindling, the mite numbers peak, and right at this point the mite to bee ratio is out of control. So what was just fine here in July, here in September is a dead colony waiting to happen. So this phase shift is an important thing to understand, and it's an important thing to urge you to make certain that those summer bee numbers don't bring along with them a crazy high mite load. Okay, so late fall and winter, as the fall flow stops, the bees get tense. So if any of you guys have noticed that you can go out and walk in your bee yard in shorts and a t-shirt in May, but trying that in October is going to leave some lumps and welts. Well, that's because there's so many bees out in that bee yard, there's not a whole lot for them to forage on, and there's a lot of robbing activity from one hive to another. So the tensions are high. So I won't read all this because I know I just said most of it. So you can spot robbing by watching bees fly at a hive. If they don't go directly to the front door like they're familiar with it, and they fly around the lid, or they're trying to get into cracks on the side of the hive, those are robber bees, and you might want to consider taking some type of action. And by taking action, I usually mean reducing the entrance size, If you've got a crazy chaotic situation and you know specifically which hive is the culprit, you can open up the top of that hive, which will sort of kind of make that hive have to turn into defenders as opposed to offenders. So robbing can destroy a colony fast. Robbing can pass veromites and diseases from failing colonies to otherwise healthy robbing culprits. This can lead to a dramatic upshift in mite load for the robbing colony at a time when we wouldn't normally think that the mite load should be increasing. So this is another reason why close monitoring of mite load from the very beginning to the very end of the bee year is very essential, because even if we follow this stuff with logic, stuff can get crazy real quick, and getting crazy real quick can mean a dead colony to clean out in April. When the temperatures drop below around 55 degrees, the bees start to form their winter cluster. This cluster can generate heat via the vibration of their wing muscles of some of the bees, and they maintain that heat by varying the size or density of the cluster. At the start of the cluster, there's normally a bit of brood left right in the middle, and by mid-November that brood will have hatched, and that cluster can drop their internal temperature from around 93 degrees to about 85 Fahrenheit. So that allows for less energy to be exerted. As winter progresses, the winter cluster will migrate throughout the hive, accessing stored honey throughout the winter. Warm and sunny winter days will provide an opportunity for cleansing flights for the bees, and can be seen in any bee yard on a sunny day in January with bee poop covering the snow. And if you have a telescope out, you'll see that it covers the telescope as well. So that's nice. As bees die throughout the winter, and they will die, every single summer bee in that hive is going to die before spring. They're going to fall to the bottom of the hive and hopefully, usually, get carried out by bees that are doing mortuary duty as the opportunity allows. So if you see a bunch of dead bees littering the snow outside of your hive, don't be alarmed. That is the exact normal course of action. Be alarmed when there aren't any dead bees out, because that means probably that there are no mortuary bees, because they are dead as well. So moisture can build up on the inside of the hives during winter, and too much moisture can present a problem for the bees, with liquid condensing and falling onto the cold cluster. Proper ventilation is helpful in avoiding too much moisture. Now, there are differing schools of thought in terms of moisture in the winter. Dr. Tom Seeley is one that suggests that it is essential. That's one of the ways that the bees get fresh water throughout the winter. And so me not having the level of knowledge of a Dr. Megan Milbreth or a Dr. Tom Seeley, what I like to do is make sure that I allow the bees their ability to regulate that. And by that I mean just allowing ventilation, allowing a full open bottom entrance and a top entrance on the top, and then the bees can sort of regulate the humidity themselves. Other things that I don't have any problems with are quilt boxes and pine straw, or not pine straw, but like pine chips up above a screen to kind of wick away the moisture. There's nothing wrong with that. I've seen very high success rates with that stuff. I don't do any of it anymore because I like to let the bees figure it out. So the one thing that I do make sure is that they have proper ventilation, and that I recommend that you do for your bees as well. Okay, winter, spring, we're kind of coming toward the end of this here. After the winter solstice, the bees will start to rear brood again. With this brood nest comes a need to raise the thermostat, and comes the risk of chilled brood and bees due to wild temperature swings. In my experience, locally adapted bees handle this issue far better than imported bees. I've seen this year after year after year. The imported bees often get European foul brood early in the spring, and that is usually because they're trying to rear brood way too fast. The first sign of warm weather, they just think, oh, this winter that we're not used to is over, let's get back at it. And so they'll rear a large brood nest. And what happens in that case is, in Michigan, the temperatures just go crazy after the winter solstice, between the winter solstice and May. So there are many times where the temperatures will vary quite a lot. And that can cause that brood nest to get chilled, because there's not enough bees and not enough food to keep the entirety of the brood nest warm. And then with that chilled brood, leaves a bacterial sink. So what happens a lot of times with chilled brood, especially in the early spring, is European foul brood. So you'll start to see twisted stomach ache position larvae and yellow orangish brood food around it, and it's real gross, and you usually have to use an antibiotic to clear it up. So this is one of the areas where I think locally adapted bees are superior wherever you're at. Whether you're in Georgia, get Georgia bees. You're in Michigan, get Michigan bees. Get something that has spent some time in the area that you're planning on keeping them, because stuff like this can cause Georgia colony and Michigan to really have a hard time transitioning from winter mode to summer production. So until the first blooms in March, the brood nest will slowly grow and the cluster will continue to migrate throughout the hive, accessing honey as they go. As the temperature increases, the cluster density decreases and the brood nest grows even more. And then bees in the very late winter, early spring, are often light on honey and can be susceptible to starvation. My advice to you for that, and we're coming up to that time now because it's the 11th, I think, of February. My advice to you is to go out and just lift up the backs of your hives. If they're super light, give them some dry sugar. And then also you can give them wet stuff if it's warm enough for you. Okay, so that is it for this portion. Once again, I appreciate the heck out of you watching. I hope you guys got something out of this presentation. There's so many more iterations to go. As you can see, the next portion will be on swarm science. So yeah, I hope you like it. I hope you stick around for more. I hope it's not crazy cold for you guys outside, so you can go out and have some fun with your bees. I can't wait until I can do that, and so I can be making videos out with my bees for you guys. But until then, I'll keep making these, and I'll keep saying thank you very much for watching. Have a good rest of your day. See ya.